LMK, the luminance measuring camera, comes with LMK LabSoft software and various focusable standard lenses. The number of lenses depend on how many a customer has ordered. To start working with the LMK, first you have to place your desired lens and mount it on a tripod or any other mechanical stable stand. As soon as the camera is attached to the power cable, it starts looking for signals. Therefore, in order to keep your camera from going into a sleeping mode, always attach the network cable before the power cable. When opening the software for the first time, the first step is to copy or import the calibration data of the camera and the lens in use. You can do so by going into Camera, New Calibration Data. In the appearing dialog, select the calibration data in the calibration folder of your software and copy the files to your computer. After importing the required calibration data, select Camera and Lens will be the first dialog to appear. From the options given in this dialog, you can select the required lens by matching either the serial number, which is written on the hardware of every lens, or its focal length. In this example, we are using 25mm camera lens. This is how the live view of the 25mm lens would look like. And you can easily see the camera and lens information in the status bar. You can place the camera or lens not only when the program is started, it is also possible to change either camera or lens or both, even when the program is still working. As an example, we are going to change the previously used 25mm lens with 8mm lens. On the computer, where the LabSoft software is already opened, go to Camera, Change. The dialog Select Camera and Lens will appear once again, from where you can select the right lens. This is the live view of 8mm lens. Once again, you can check the camera and lens information in the status bar. There is also an option of using evaluation version of the LMK LabSoft software that does not involve the use of hardware. For that, you will have to select No Camera, No Lens option in the Select Camera Lens dialog. Moreover, if there is no camera attached to the computer, this dialog will not appear when starting the software, and the software evaluation version is started automatically. The camera and lens are delivered with calibration data needed for their later use. Before capturing an image, some adaptations are necessary. A sharp optical image is of great importance, especially when measuring the luminance of a very small object. In order to set the most suitable camera exposure time, set the camera into live mode. When the camera is in the live mode, it continuously captures and displays images. You can see the live video stream in the Camera Image tab. The permanent capture mode or live mode of the camera can be closed via Camera Freeze. This is called the freeze mode. Alternatively, a single camera image with the current exposure time is captured via Camera Grab. With the help of exposure time, the image can be made brighter and darker. It is important to adjust the exposure time because when you start analyzing a light source, you see gray areas and red areas in the live stream. The red areas are oversaturated areas and they represent the value above the adjusted measuring scale of the LMK. By changing the exposure time, you can change this measuring scale. LMK LabSoft is equipped with different tools that aim to reduce and remove the oversaturated areas. In order to adjust the exposure time, you have 3 options to achieve it. With the help of manual exposure dialog, you can increase or decrease the exposure time values to set brighter or darker values in the live view image till you achieve the ideal saturation in the image. You can either put fixed numeric values in the brighter and darker box or use the adjustment buttons for that. You can select automatic exposure in the exposure time dialog, which will adjust the brightness and darkness ratio in the image automatically. This is usually applied to brightest objects in the image regions where a suitable exposure time is selected by the program itself. You can click Auto Scan in the exposure time dialog. This also sets the exposure time automatically. However, Auto Scan is more intelligent than automatic exposure and could therefore speed up finding the correct settings. Furthermore, it is possible to apply Auto Scan to predefined parts of the image which must not be the brightest. This is possible via the usage of rectangular surface regions. If there are bright glare sources outside the area of interest, they will provide overdrive in the image. The image area for analysis is selected via Capture Set Region for Overdrive Control and through its resulting dialog. Once again, you can click Auto Scan, and when the brightest parts of the area of interest are not overdriven, then this image is said to have optimal brightness. Before capturing an image, the brightness of a scene to be captured can be adapted by selecting either a suitable exposure time or a neutral density filter. Neutral density filters enhance the measuring range of the camera in case of a very high luminance. Take the filter you want to use and mount it in front of the lens of the camera. If a neutral density filter is in use, and if the corresponding factor is available in the calibration data, then the filter in use can be entered into Capture Properties, Gray Filter box, after pressing the button Change. Please note that this video is focused on LMK5 model type series only. This tutorial does not contain more detailed information about color measurements. In order to set up a color camera, you need more steps regarding color configuration depending on the light sources you want to analyze. It is important to adjust the focus of your camera's lens before starting the analysis. Focusing means to adjust the sharpness of your camera image against the structure present in the template image. The focus of the lens is adjusted either through the focusable lens or, in case of a non-focusable lens, adjusting the appropriate capturing distance. When working with a focusable lens, a calibration factor changes depending on the distance settings of the lens. In such a case, the scale value has to be read from the top of the lens, indicated by a small silver marker. The button Change in the line focus has to be used, and the focus value desired has to be selected in the dialog. The software offers some tools for checking the sharpness of focus. It is possible to use the line cursor for creating a sectional view to check the quality of edges caused by different brightness levels in the image. The diagram at the bottom shows the gradient and maximum value of brightness depending on the set focus of the lens. The aim of this focusing procedure is to maximize the pixel space shown at the x-axis. Also, a resulting aim is to maximize the brightness level at the y-axis. The unit at y-axis is digital grayscale.